Hi, I'm Mike, former business person and teacher. It's December 3rd, 2020, and I'm going to try to explain how the COVID vaccines from Moderna and Pfizer work. The FDA is likely to approve these vaccines soon, and they'll be the first of their kind using messenger RNA technology. I'll be using layman's terms to make this understandable to most people, so immunologists will have to show me some patience. Your body fights off bacteria, fungi, and viruses with white blood cells. White blood cells make up about 1% of your blood. Let me show you a picture of a vial of blood that was centrifuged. So as you see, the top portion is plasma, bottom portion red blood cells, and the middle portion white blood cells. Your body will encounter several viruses over your life. The 5 common types are rhinoviruses, which could give you a head cold, coronaviruses, which can give you a chest cold, influenza viruses that may give you the flu, metapneumovirus that can give you pneumonia, and HIV that may give you AIDS. The current coronavirus disease began in 2019, hence the name Covid-19. It is caused by a strain of the coronavirus. The strain is called Severe Acute Respiratory Syndrome Coronavirus 2, SARS-CoV-2. And by the way, COVID-1 came in 2003 and caused SARS. One particle of the coronavirus is made up of one very long strand of RNA encased by a sphere of proteins with spikes and an outer layer of lipid. The RNA is the set of instructions on how to build another virus particle. The ring or strand of RNA is made up of a chain of 4 types of nucleobases: guanine, cytosine, uracil, and adenine. A phosphate holds them together. They are fairly simple compounds formed by different combinations of just 3 elements: nitrogen, hydrogen, and oxygen. The nucleobases are abbreviated G, C, U, and A. The RNA strand of COVID-2 has 29,811 nucleobases. So even though I've only shown 100, there's 29,000 of them. Now I'll get into exactly how the Moderna and Pfizer COVID vaccines are manufactured. Earlier this year, scientists determined which segment of the 29,000 long strand of the virus contains the instructions on how to build the spikes on the outside of the virus, including their size, shape, and construction materials, which are proteins. They then built one of these segments in a high-tech machine, starting with the first nucleobase, adding the next one, getting them to combine, and then adding the next one until the whole segment is completed. I've only shown 21 here, but I really don't know how many are total in the actual segment. Multiple segments are made and then placed in a container with a liquid, which is then stored in a freezer at -94 degrees Fahrenheit for the Pfizer vaccine and less cold for the Moderna vaccine. Once out of the freezer, it can be in a refrigerator for up to 5 days. A hypodermic needle is filled with the vaccine and then injected into your arm. Your bloodstream absorbs the liquid with the synthetic RNA or messenger RNA, mRNA. A booster shot is given 3 weeks later. After injection, you may feel fatigue and aches as your body's immune system gets to work. You may also have a little pain at the injection site. Now I'm going to explain what I mean when your immune system gets to work. When a white blood cell comes in contact with the mRNA, it'll take it in and then build onto itself spikes made with proteins to mimic the ones on an actual coronavirus particle. This uniquely spiked white blood cell will flow in your bloodstream, bumping into countless other cells. Some of those other cells are B cells, a type of white blood cell. B cells have receptors attached to proteins. Think of a jigsaw puzzle piece. Your body continuously makes billions of B cells, each with a mostly unique, randomly designed set of receptors on its surface that bind to different types of proteins. When the appropriately receptive B cell comes upon the white cell with its unique protein spikes, it will bind to it. The B cell then envelops the spiked cell. It'll then partially break it down in order to find the part of the protein that bound. The B cell then hangs that part of the protein on the outside of itself so that a T cell, another type of white blood cell, will attach to it. After attaching, the T cell instructs the B cell to start the process of making more of these effective receptors called antibodies. These antibodies flow through the bloodstream where, for a few months or so, they have the opportunity to do the same work the first B cell did, that is, to attach to spikes. The spikes can be more of those on the white blood cells that picked up the vaccine's mRNA, or on the actual virus particle. At this point, your body is able to kill virus particles, hopefully faster than the particles can kill you. Moderna and Pfizer vaccines have demonstrated their ability to get your body to make antibodies for at least 3 months. Sometimes, after a T cell instructs a B cell to make antibodies, it will update the immune system's memory file by creating memory B cells so that it can quickly kill the virus if it comes again several months or years later. This is the fancy way of saying you can only get it once or the vaccine works for years. These memory B cells store information on what pathogens got into your body and what types of cells your body successfully used to kill them. Just like you know how to use kryptonite to kill Superman, a wooden stake to the heart to kill a vampire, or a sword to the heel of Achilles. Your body's use of memory B cells speeds up the attack against a pathogen by days or even weeks, which can be the difference between life and death. Whether or not the Moderna and Pfizer vaccines result in your body creating memory B cells for long-term immunity is unknown at this time. If your body were actually infected by the virus, the T cells I mentioned earlier would aid on that front too. The T cells would activate other T cells to go and kill your body's own cells that are harboring virus cells to protect from spread. Memory T cells keep a record of this for possible future infections. Pfizer claims that 80% of its vaccinated participants showed a strong memory T cell response, and Moderna claimed a weak memory T cell response. Now I'm going to talk about the effectiveness claims. The 95% effectiveness claim refers to your body's ability to fight off the virus in the short term, not the long term. And it only refers to the current form of the virus and not mutations. I want to talk about the calculation of the 95% since I used to teach math. That 95% comes from looking at how many people got the virus after receiving the vaccine and those who got the virus after receiving a placebo. Pfizer reports that of its 44,000 participants, 8 people tested positive for the virus after receiving the vaccine, and 162 got COVID, tested positive, who didn't get the vaccine. So 162 out of 170 equals 95%. If you're exposed to the virus several months after receiving the vaccine, your ability to quickly fight off the virus is dependent upon memory B cells, which we don't yet know will be there in the long run. People exposed to SARS-CoV-1 in 2003 did not have memory B cells for that virus years later, but they did have memory T cells. These vaccines are the first of their kind to be commercially available. The manufacturers will continue to monitor the health of the people in their trials to look for negative long-term side effects. I have not seen anything demonstrating the manufacturers' concerns about negative long-term side effects. I'm not going to go into the issue of whether or not you should get the vaccine. The purpose of this video is to inform you of some of the aspects of the vaccine so that you are better equipped to watch the news, read things online, and have a conversation with your health professionals. I wish you good health, and thanks for watching.